Hey guys, welcome back to the channel. Today is February 8th, 2026, and it is a chilly one out here. You know that feeling? You hop in your car, turn the key, and it fires right up, purring like a kitten. The engine feels perfectly fine. No weird noises, no shaking, nothing to suggest there's a problem brewing. But then you glance down and see it, the dreaded check engine light. It's a silent little warning that something isn't quite right under the hood. In our case today, we've scanned the car and pulled a P0135 trouble code. Now, that might sound complicated, but I'm going to break it down so it's super simple to understand and fix. So, what is a P0135 code? Or the O2 sensor? Think of your engine as a chef trying to get the perfect recipe. To do that, it needs to measure its ingredients very carefully. The O2 sensor is the tool it uses. It measures how much oxygen is left in the exhaust after combustion. That tells the engine if it's using too much fuel or not enough. Then it makes tiny adjustments for the perfect air-fuel mix. When the sensor's heater fails, it can't reach operating temperature quickly enough, so the engine doesn't trust its readings. The ECU then goes into a pre-programmed backup called open loop. It stops measuring. It starts guessing. It runs a default rich fuel map, safe but inefficient. Your car is dumping extra fuel into the cylinders to be safe. That guessing wastes fuel. You'll be visiting the gas station more often. Over time, running open loop can cause premature wear on the catalytic converter, a far pricier repair. So let's get this sorted out. The good news, P0135 is often an easy fix. You don't always need a costly new part. Before you grab any tools or even think about spending a single dollar, we're going to start with a simple but crucial visual inspection. I call this the $0 fix because many times the problem is something you can spot with your own two eyes. The wiring for the O2 sensor lives in a very harsh environment. It's routed right next to a scorching hot exhaust. It's exposed to water. It's exposed to salt. It's exposed to grime kicked up from the road. Over time, this can take a toll. So, the first thing we're going to do is trace the wires coming from the O2 sensor back to its electrical connector. Get a good flashlight and take a close look at the entire length of the wiring harness. You are looking for anything that seems out of place. Check for sections where the plastic insulation might have become brittle. Check for cracks in the insulation from heat. Look for spots where the wires rub against a metal bracket. Look for spots where the wires rub against the engine block. Those rub points can wear through the insulation and cause a short. Pay special attention to areas that look melted. Pay attention to areas with black soot. That's a dead giveaway. The wire touched the hot exhaust, shorted out, and is likely the cause of your P0135 code. If the wires look okay, inspect the electrical connector. Follow the wires to where they plug into the main engine harness. Carefully disconnect the connector. If the release tab is stiff, be patient. Don't force it. Once apart, look inside both ends of the connector. A poor connection here is just as bad as a broken wire. Finally, check the fuse box while you're in inspection mode. If your visual inspection didn't turn up any obvious culprits like a burnt wire or a blown fuse, it's time to bring in our best friend for electrical diagnostics, the digital multimeter. This tool will allow us to test the components and get a definitive answer. We're going to start by testing the heater element inside the O2 sensor itself. This is a simple resistance test that will tell us if the heater wiring is intact or broken. Don't worry if you've never used a multimeter before. I'll walk you through it step by step. It's easier than you think, and it's a skill that will save you money on future repairs. First, set your multimeter to resistance mode, the omega symbol. Select the 200 ohms range if your meter has multiple settings. With the O2 sensor disconnected from the car, probe the pins on the sensor side of the connector. Identify which two pins are the heater circuit. Polarity doesn't matter for resistance tests. Now look at the multimeter screen. A healthy heater reads low resistance, typically between 3 and 15 ohms at room temperature. Chasing the power testing the harness for voltage. Okay, so let's say your resistance test showed that the sensor's heater is good. That means the problem isn't the part itself, but rather the power and ground supply going to it. Now we need to shift our focus from the sensor to the other side of the connector, the wiring harness coming from the car. We need to verify that the sensor is actually receiving the power it needs to operate its heater. For this test, we're going to switch our multimeter from measuring resistance to measuring DC voltage. This is a live test, so make sure the car is in a safe position, preferably in park with the parking brake on. Set your digital multimeter to the DC volt setting, usually indicated by a V with a straight line and 3 dots next to it. If your meter has ranges, select the 20-volt range, as we expect to see a voltage close to that of the car's battery. Now, go to your car and turn the ignition key to the on position. Do not start the engine. In many cars, the computer sends power to the O2 sensor heater as soon as the key is turned on. With the key on, we're going to carefully probe the pins on the harness side of the connector, the one that leads back to the engine. You'll need to identify the power and ground pins for the heater circuit on the harness side. Again, a wiring diagram is your best friend here. One of these pins should be the power supply, and the other will be the ground. Place the red probe of your multimeter on the power supply pin and the black probe on the ground pin. You should see a reading on your multimeter that is very close to your car's battery voltage. The verdict. When is it time for a new sensor? By now, we have gathered all the evidence we need to make a final, confident decision. We've moved beyond guesswork and used real diagnostic steps to narrow down the source of our P0135 code. Let's review our findings and determine the correct course of action. Decide whether to spend money on a new part, or focus our efforts on a wiring repair. Making the right call is the key to fixing it right the first time. Don't just throw parts at the problem and waste time and money. The decision to replace the sensor is clear if your multimeter showed OL when testing the heater pins on the sensor itself. As we discussed, OL means the heater element inside the sensor is broken. It's like a burnt-out light bulb filament. No continuity, not repairable. In that case, the sensor is definitively bad. You can order a new one with confidence. It's the root cause. No need for more harness-side electrical tests. The part failed. If the sensor's heater resistance tested good, for example, you got about 8 ohms, but there is no voltage at the harness connector when testing for power, do not replace the sensor. A brand new sensor won't work without power. The right part for the job. Choosing and installing a replacement. So, your tests have confirmed it. You need a new oxygen sensor. Now comes an important choice that will affect longevity and performance. It can be tempting to go for the cheapest sensor you can find online, but I strongly advise against it. When it comes to critical engine sensors, quality really matters. Cheap, no-name sensors are notorious for having slower response times, inaccurate readings, a much shorter lifespan. You might save $20 today, only to be doing the same job again in 6 months when the cheap part fails. Your best bet is to go with either an OEM, original equipment manufacturer, Denso, NTK, Bosch. These companies are often the original suppliers for the car manufacturers. They are designed to match the exact performance characteristics your car's computer expects. A quality sensor will respond quickly and accurately, helping your engine maintain the perfect air-fuel ratio, which translates directly to better fuel economy, lower emissions. Before you install your new sensor, there are a couple of important preparation steps. First, let the exhaust cool down completely. That pipe can be incredibly hot and can cause a nasty burn. Once it's cool, use a specially designed O2 sensor socket and a ratchet to remove the old sensor. These sockets have a slot down the side to accommodate the sensor's wires. Sometimes the old sensor can be seized in the exhaust pipe, so you may need to apply some penetrating oil and let it soak for a while. Once the old sensor is out, compare it to the new one to make sure the connector and thread size are a perfect match. The final check. clearing the code and confirming the fix. Alright, the new sensor is in. The connector is clicked into place. The wiring is secured. We are on the home stretch. Final step. Clear the P0135 trouble code. Verify the fix was successful. Even though you replaced the faulty part, the check engine light won't go away by itself. The computer needs to be told the problem's fixed. Use the same OBD2 scanner you used to read the code. If this guide helped you, don't forget to subscribe to the Fix Car Codes channel and turn on notifications so you don't miss the next real-world fix. Let's keep your car running right.